everyone, hello. Excited to be here, especially because we've negotiated the date with Michael a couple times, and finally, after months of back and forth, I'm here to happy to introduce you guys to Michael Mattsson, who is the CEO of Svexa. Michael, just tell us about yourself.
Yeah, as you said, I'm the CEO of Svexa. I'm one of the four co-founders. I have a background in science, in exercise physiology is my PhD in from Karolinska in Sweden. Originally from Sweden, worked with athletes for 27 years now, and in academia for 20 roughly, and in the industry now for since 2008 when we started Svexa.
Okay, it's a huge background. And when we've talked with you before the recording, you've told me how the Svexa started and how much knowledge you guys had when you were starting, like a lot of knowledge, combined knowledge. Tell us the story, the beginning.
The beginning. Yeah, as you said, the four co-founders are all PhDs and professors. So a lot of academic knowledge and a lot of practical knowledge. So having that intersection between the practical sports world, the scientific sports world, but also data science. So it's a spin out from Karolinska in Sweden, where work and exercise physiology has been best in the world for 75 years or so. And then Stanford with precision medicine from Stanford. So that combination was the reason, I think, why we started. So I moved to Ewan Ashley's group at Stanford. He's now the chair of the Department of Medicine there, and he's one of the co-founders of Svexa in 2013. One of the other co-founders, Daryl Waggett, was there as well, in bioinformatician and doing a lot of the data handling and data analysis. So in those years, we were very well positioned to work with all the big tech companies when they wanted to go into health around that time. Everyone was trying to do a wearable, go from when I started in exercise physiology, no one in I don't know how to call it, real science cared about exercise physiology, but that's obviously very, very different now. So we got more and more requests from pro sports teams. This is before we started Svexa. So got requests from the tech companies about how to do things and help them validate and do studies on what technology would be good enough to use in a clinical setting. And then on the sports side, at the same time, we got requests from pro sports teams around what technology should we use, what genetic test would be the best. And then it turned into, can you do anything with our data? And this is around 2017. We realized that, yeah, we can. We did a couple of pilots with soccer teams in England and showed that we can, in a really good way, if we have enough data, forecast injuries. That was the first thing they talked about. And then we also realized we can use all of this data that wasn't available a decade ago to optimize performance. We can use the data that people were collecting, athletes were collecting, to get their performance prediction at the time, but then also use that to forecast if they did training program A or training program B, which would give them the best results going forward. So from then a company perspective, we felt that the planets were aligned, so we should start the company and that we had really something that was unique. And since we knew what the big tech companies were doing and we'd been in the industry for quite some time before having our own company, we could carve a niche for Svexa where we said that we're going to be the intelligence layer. We're not going to build new hardware. We're not going to be the platform. We're not going to be an athlete management system. Instead, we will take it to the next level, not just display the data, but use it to forecast and use it to optimize the performance, tell people what would be the best for them to do in that specific instance. And that's pretty much what we've been working on since then. So it's going into the 8th year now of working with this company.
That's really interesting. So when you're talking about working with data and adding this intelligence layer, like you said, with what exact data have you started working at the beginning of the company? And maybe you expand it more right now. What data do you use?
Actually, we started with more and worked our way down to as little as possible. So the situation with the soccer teams in the early days was that they had been collecting data for a lot of years, but they didn't utilize that data or analyze it from different areas combined. So I think we had 10 or 11 different data streams in the first analysis, meaning that for those soccer teams, they had their GPS tracking, they had heart rate, they had resting heart rate kind of starting points of the day, they had obviously anthropometric markers. They also had physiological testing, psychological testing, blood and saliva markers, and so on. So they had a lot of different things already. And we know then if we got 3 years of historical data and we get many data streams and good coverage, we can be very accurate. But that's not going to be possible for most of the people. So most of the people will have very little data. So when we had done team sports and when we had done injury risk forecasting to begin with, we said that the biggest problem here, I shouldn't say biggest, I should say one of the problems here is that the easiest way to avoid the injury is to not expose. Meaning if you don't train, if you don't play games, you're not going to be injured, and you don't want that. So instead, we need to focus on performance optimization. And with that, so every time you flag someone, every time you tell someone not to train or train less, it should be because it's a net positive. They gain more days of training so that they can train more and therefore be better. And performance optimization is a little bit hard or very hard or impossible depending on who you ask in team sports. Can you quantify how good was that defender in that game? And was it better or worse than last week? So then we said if we're gonna prove this, that it works and that our algorithms are good, we need to have more standardized sports. So then we went into swimming. That was the sport we had contacts to and also felt that this is the most standardized. You don't have any environmental factors. In the shorter races, they go all out. They compete quite often, so you have a lot of data points. And then we could prove that with our model, we could be very, very accurate in performance predictions. When I say very, very accurate, we're at the, as I said, highest level of scientific knowledge. So we're and also competitive athletes. So we know that we can't be that far off for it to be valuable. If it's off, it's not gonna bring any value to the table. So what we were able to do was that first time we did this is in 2019. So it's before the pandemic, and for the World Championships in swimming 2019, we had data for Swedish swimmers, and we gave the results to the coach, not the athletes, before the championship started, and sat back and relaxed, and we were, I shouldn't say surprised, but it was their positive results. So the accuracy, the average error was %. So we were off by 35 hundredths of a second in a 200-meter race. And that's very, very accurate. And then obviously, then we can use that. The most important thing is that we can use that to model the future. And then we can say, for this athlete with this profile, we can model what happens if you increase the training load 5% the first week and decrease it 3% the next week, and then run thousands and thousands of simulations, and then pick the theoretically best one to train the most, get the best results, and also peak at the right time. But again, this is elite athletes, it's swimming, very controlled, a lot of data, several data streams. So again, not that valuable for general population. So then we continued on to how little data can we use. And be at give some good value. 2021 we worked with runners and tried, if we don't know anything about people that are going to run a 10K race, we gave them a Garmin watch and our subjective ratings questionnaire, so how they feel about their situation, if they felt that the training was hard, how much energy they have, just rate how they felt that they slept and their nutrition and all of that. So 8 weeks from not knowing anything, collecting data for their trainings like 3-4 times a week, best case scenario, and their daily ratings. We could, in that scenario, predict the race time after 8 weeks with an average error of 3.8%. So it's an order of magnitude bigger error, but it's still within 1 minute in a group of runners that were from like 35 to 60 minutes. And if we have that little data and can be that accurate, it's relevant for the general population. It's relevant for recreational runners that are training for a marathon and how they should and could train for optimal performance.
Yeah, so Michael, it's just mind blowing, okay? I'm hearing this for the second time, but all the time I'm like, how are you doing that? Let's say in terms of, give us a breakdown, a secret sauce, if we could say it, like, let's say in terms of the runners, right? How do you predict, like, which data points, you've mentioned some, but how do you connect them? And it's probably a really tough question because that's the core of your business. If you could high level explain that.
Yeah, I can try to explain. So what you have is obviously you have data points when someone is running, and you have data points of how they're feeling, and you have data points of the environment, and you have data points on if they are improving or not improving. And we all know that people respond differently to the same type of training. So you can imagine that you get more of the type of training you respond good to and less of the training that you respond poorly to. And when we don't know anything, so this is as a key aspect of our secret sauce, if you will, is that we know that we can be this accurate if we have a lot of data. And we can't wait 3 years and tell someone you need to get all of these gadgets and train for 3 years and then we're gonna give you a good prediction. So we knew from the beginning that we need to both be agnostic to the type of gadgets, so we can work with any gadget. And that took us a lot of time, or takes us still a lot of time to make sure that we have harmonization between different gadgets and all the different aspects. And secondly, that we have hierarchies. So if we don't know anything about you, again, we come from the intersection between practical knowledge, scientific knowledge, and data.
Mm-hmm.
So it's not a pure AI data play. We can do that when we have the amount of data, but we also need the domain expertise to be able to know if we don't have the data, how do we fill the gaps?
Mm-hmm.
As an example, is a 0 a 0 or is a 0 a fill forward? To be a little bit technical. So this is something we can go back all the way to the team sports athlete and the soccer clubs. They had their great control over their athletes and a lot of data for 3 weeks, and then they had 10 days of break because they sent the players away on national team duty and they didn't have any data. So that doesn't mean that they didn't do any training. It just means that you didn't do it. So how do we add that to the calculation? And that's part of the domain expertise. And at the kind of lowest level, we don't have the data. What can we tell you? And obviously, if we don't have any data, we can't tell you specifically about you. But within our team, we have the competence of writing training plans. So when you start and we have nothing about you, you would get the most common approach for a runner, let's say. So scientifically sound, this is the training plan that you should likely be okay for you because of all the science in the background. And then we know a little bit about you. We can narrow that down to people like you. And then we can narrow it down to even a smaller group of people like you. And then we can go to using your data over time. So part of our approach is I should say, part of the secret sauce is knowing what data to use and how to use it and how they interact.
Mm-hmm.
And another one is to have the hierarchies and understanding what matters and what's not there, so that the experience to the user should be as smooth as possible. So we have from the beginning said that people are not necessarily interested in, or in our case, shouldn't look at the numbers themselves. They are interested in what should I do today?
Mm-hmm.
And then that what should I do today is not a static plan over 12 or 16 or 20 weeks. It is something that is changing based on what's happening in your life.
Mm-hmm.
So with that, your question was really how does it work and how do you do it? And the key is to take all the data. So if you think about any wearable, they would have data in one format. So it might come from a ring, it might come from a watch, and then they have to extrapolate the outcome from that. Whereas we are in the fortunate, luxurious position of being able to take all the data. So it's obviously easier to do a good estimation if you have the load data, if you have the mental stress data, if you have the sleep data in combination with the activity data and so forth. And then part of the secret sauce is understanding what data points to use. Not all data points are created equally. And that's important to take into account. And that means that just throwing big data analysis on biological data is not going to work very well. It's going to be okay, but it's not going to work very well. So you need layers of cleaning the data, picking the data points that are relevant, and have structure for that, for it to be at the accuracy level we are looking for.
So that's where your main expertise as a scientific, people comes from, to understand which data to understand which data is more valuable than another, and etc.
I can give you one example to be a little bit more concrete.
Yeah.
So before we started Svexa, me and Philip Larsen, one of the other co-founders, we were both exercise physiologists. So we were asked to work with startups before Svexa. So we've advised, I think, 7-10 different companies before we started Svexa. And one of those companies were a wearable. So this is before Apple Watch and all of the wearables. They had the technology to measure heart rate with light on your wrist. So very early days prototype and getting a watch out. So we worked with them to create algorithms for training and getting load metrics and the basic stuffs. And they had great engineers, and we were in the phase of evaluating the product and seeing if the data made sense and all of that. And something was wrong. So it took us forever to dig through all the data and find out that you had peaks of heart rate up to 400 that were included in the calculations. Because for the engineers, heart rate was just a number. So it was not weird for them to have a heart rate of 400. But for physiologists, it was like, make sure to cap that at 250. Everything that's outside of 250, let's say, is going to be a false value. And that would have saved us a lot of time in debugging that product. And it would allowed us to move forward faster, and it would have allowed us to be much more accurate. That's just one example. So you can imagine all of the biological data that you're working with will have those types of outliers. Another example, you would think that heart rate and speed, for example, is a very strong correlation. That someone is running a little bit faster, they're going to have a higher heart rate. And then you run a little bit faster again, you're going to have a high heart rate. That is true in a steady state situation. Whereas if you look at a printout from a run in the city, it's all over the place. Because you will have high heart rate and stop at a traffic sign, and you would have low heart rate but high speed when you go off again or start after that traffic light. So you need to know what of the data points in that heart rate file is actually representative of the performance level. So these are just simple examples, but you would be able to have that. And then you can kind of layer that in, so you can have, well, was it a hilly run? What was the temperature? What was the altitude? What was the surface? So we have, for example, surface detection in the accelerometry, so we can correct for if you're running on grass or asphalt or gravel or a track, so that we can adjust the calculations according to that.
That's really interesting. A lot of things to think about. I'm pretty sure everyone who is listening to us is shocked as I am. And you mentioned that, right? You're using your expertise to find these small details, and you just showed us a couple examples. I'm curious, how does AI and machine learning, is it shaping your company in some way? Are you implementing it? And how will you see it will affect?
Yeah. So our investors are sometimes upset with us nowadays because we don't print AI over everything. We are an AI native company. So one of our very first engineers was then headhunted. First AI engineers, actually the engineer that was working on the swimmers in the early days. He was then headhunted to Meta and worked on DeepMind, on Google DeepMind. for quite some time. So we are an AI company. We've been an AI company since we started. It's a little bit like saying electricity in our world, meaning that you need it everywhere, and everything from different types of AI, like fraud detection that you have in the bank and financial system. We use similar algorithms for what we talked about there with metrics that are outside of what should be included. We can use fraud detection AI models for that. When I mentioned that we give you more of what you respond well to and less of what you respond poorly to, that can be considered a type of reinforcement learning, one AI technology. But then in these days, most people talk about AI, they mean LLM or just a generative AI text video generation. And for us, that's more of a user experience situation. So we are more on the, as I said, intelligence layer background, using the AI to figure out, for example, in forecasting. Based on all your data, what machine learning models, what layers can we use to forecast when you're going to be injured again based on all your historical data? Whereas, of course we can use the AI to LLM style AI to have a conversation with your, but that's typically on our client's side rather than our side.
And then, who are your clients then? I saw you're serving B2C at this moment.
Yeah, our clients are as I said, we started in the sports world, so elite athletes. So we have clients that are pro sports teams and leagues around the world. We have sports federations that are our clients. We work with their athletes, but that is our starting point. And we started with elite athletes because they are in a controlled environment, more or less. Yeah. They have a lot of data and they have a clear goal that they're training towards. So for us, that's a very, very clean and good sandbox to develop algorithms. And then that's a pretty small market, really. Excuse me. And then we talked about how little data we can use. And then it's about the recreational athletes. So in that field, we work with platforms, so race organizer platforms for running races or cycling races, or training platforms that then include our algorithms to as an intelligence layer in their platform. Or we talked a little bit about team sports, we talked about endurance, we also have strength training module, meaning that we are also in strength training machines, the connected fitness machines. They use our algorithms for same thing, really, to recommend training, to have weight setting. What weights should this person have for it to be as good experience as possible and as high improvement as possible, progression over time.
Mm-hmm.
So that's where we are now. And then our approach has always been to go towards the general population and be able to take what we know and how we do it for the elite athlete and democratize it to everyone. So that's one of our starting points, that at the top of the pyramid, if you will, you would have the elite athletes, and they have their entire coaching staff. They have their physio, their strength and conditioning coach, they have their technical coach and everything. And they get told every single day, or even within the training session, what to do, how to do it, how to change. So fine-tune everything. Whereas at the other end of the spectrum over here, you have the people that have the least knowledge and need the most help, but they don't have the resources or personnel to tell them what to do. And they get the crudest recommendations. So they get the World Health Organization train 150 or 300 minutes a week, and that's it. So how do we then take the knowledge from the best coaches and build algorithms and scale it so that they can be used by the general population, by everyone? So we have a lot of customers in the elite athlete side of things, so that we moved we expanded to more of the platforms, machines type of world, and then we're going towards the general population and more of a health play.
So the vision is like to create some kind of app, or if you have it, what is the, let's say, I couldn't say end vision, but let's say perfect scenario for Svexa.
Yeah, perfect scenario wouldn't be that we do the app. So again, in the early days when we started the company, we said that we're going to focus on our strength. We're going to pick a niche where we can shine, where we can be the best. And we're good at the sciencey side. We're good at the back end side. We're less so, or not at all good at the front end side, the user experience, the design aspect. Meaning that if we then focus all our efforts on improving the algorithms, making sure that we can take in the different data streams and understand that, and as I said, all the different ways we can improve the accuracy, we can then serve the front ends, meaning that all the apps that are out there, they can use Svexa to improve their offering. So we think of that a bit as Gore-Tex in outdoor retail, for example. You would have a Arc'teryx or a North Face or a Patagonia jacket. They all use Gore-Tex because that's the best. So our goal is to be similar to Gore-Tex in that aspect, meaning that you would go to us as a seal of excellence, and you would get the best, and we would continue to improve and update and make it better all the time. And then we would be in all the different platforms. So for running races, the first recommendation engine we released was for running and endurance sports. So that one is called, in our world, it's called Elida. We have Nordic mythology names on all the products that we release. And then they called something else on the front end for different apps. So that is now deployed in 8 different platforms in 5 different countries. So with that, we reach almost 10% of all the running races in Europe and US. But no one sees us on the front end there because they are in different platforms. So then there are so many softwares out there, so many apps. So one of the things we said, all the way back to the pro sports teams, they don't need another software. They want it to be in one place. So then if we can add value to the existing platforms, apps, that's going to be our thesis is that that's going to be good for us. It's going to be good for the app, and it's going to be good for the end user.
Okay, yeah. So I would assume the perfect scenario is to partner with some government health organizations and to integrate your algorithms into their systems.
Yes, that's a perfect example, and it's starting to become more and more prominent, and we get more and more requests around that. So we get the requests from the national Olympic committees or federations. They want to do we want to make this sport better in our country. How do we do it? How do we collect the data from a lot of people and then distill it down to optimizing the top? And then we also see exactly what you talked about, countries that are realizing that the public health, physical activity is something that is underserved, and that the typical training plans are not working. People are not adhering to that. So it would make sense. They have several countries already have those, like the National Health Organization have an app, and you can get education there, and you can get some advice. And if you then can add Svexa's technology to have your training recommendations in there. What should you do today, or when should you rest because you've done too much? It's perfectly in line with what we are thinking. And we've also done a lot of research there to show that if people do the runners there, same amount of training for 8 or 12 weeks, but you train a little bit less on the days when you are tired, fatigued, and you get a bit of a harder training session on the days when you're ready for it, then you get a better result. If you have the adaptivity in the training plan, you get a better result than if you do the same training but just a fixed plan. So that's just one example. We have a study now with blue-collar workers that meet the World Health Organization criteria for physical activity because they're active at work every day, but they are still unhealthier than the general population. So how do we solve that paradox? How do we figure out what they should do for optimal health?
Why is that? I'm so curious.
No one knows. No one knows yet. So we will be at the very forefront of scientific research there, and then take it to implementation and recommendations very quickly. So that's one of Svexa's strengths, I would say, in that we can have a research department that is working on those type of things now at the forefront. What will be the next thing? So blue-collar workers will be the next thing. How do we, on the technological side, how do we, for example, measure mental stress? Can we get cognitive stress from everything from eye tracking to voice to digital phenotyping, how you're using your mobile phone, metadata from your mobile phone? And how can we incorporate that? So that is typically not done today, but we know that it will happen. The same way with biomarkers, what will be the next batch of biomarkers that we can use? So in our world, we have that development on our scientific department. So then we're at the forefront there, and then we can very quickly take it from science all the way to available as an API, available for our platform clients to use right away. So that's key for us.
Awesome. I'm glad that I am the one who is highlighting what you do, because I think, like you said, you're at the back end, and people would never knew, just a general population, that something like that exists.
We're getting there. We know that we are a bit sciencey, a bit slow. It took us 4 years from 2018 through 2021 to be a bootstrapped company and not take venture capital and develop algorithms and see, does this actually work? And when we felt that this is really good enough, then we took in capital in 2022. So from that perspective, we're just on year 3 in being a startup in the venture capital world startup. And we've done the calculations, of course. So as you allude to, the public health aspect is a way bigger market than the sports market. And we sometimes get questions around, why didn't you just go straight for the health market? But we, as a scientific approach, we knew that it's easier to take one step at a time and then build on that. So the recommendations I've talked about are single purpose recommendation engine. You get your training plan for running, or you get your training plan for cycling, or you get your training plan for strength training. Obviously, general population, people do a little bit of everything and they're not very structured. So we need to have that adaptivity, as I talked about, but we also need to have the combination of different sports. So we just now released that. So now we have combination of different sports, and then we'll add recommendation engines of different types. So the next batch there will be around, you get your sleep recommendations in combination with your strength training, and it doesn't matter if you missed your Thursday strength training and did go golfing instead. The system will just upload and update and recommend what would be best for you to do on Saturday based on where you are, not based on what the program originally said that you should do.
Michael, that's awesome. I'd love to have this thing, because going to the gym some days might feel like a hell to me, but I'm pushing myself. And the thing you've mentioned, that you got a study that shows if you're, let's say, the day when you don't feel like, you're doing a little bit less, right? And then on the day when you feel like, crushing it, you're doing more. In the long term, you're winning. One thing, it's completely changing my mindset around. And if general population will have such a tool, that would be, health changing, I will say.
We're hoping that, and it feels like we're in a very good position now because we've been so diligent in doing one step at a time and taking the science, that we are now in a very, very good position to add layers so that you can add your... Going forward, we will, of course, want to make sure that we have all different activities, and that if you're doing garden work or if you do a extra walk, that should be included.
Okay, yeah. All right, Michael. So at the end of our podcast, I want to ask you a couple questions, a blitz question. So the first one, which is your favorite sport?
I don't have one favorite. For myself, I typically go by the seasons. So I like to change the sport based on the environment. Meaning that, as I said, I grew up in Sweden, and there would be cross-country skiing and speed skating in the winter, and it would be running and soccer in the spring and summer. And likewise, I travel a lot around the world, so trying the things that are the most watched or liked in the country is something that I really, really enjoy. I might be absolutely terrible at it, but I try to test and try the different sports.
Okay, so, but if we will say one sport, you got to pick only one, and you could never play other ones, what would you pick?
I wouldn't.
Okay, then, the next question was from the first one. Who's your favorite sport, athlete?
I would say that the type of athletes that we have in our team, those are my favorite athletes. So in Svexa, as I said, with the combination knowledge and intersection, we have a hiring structure that we try to hire former elite athletes and that are also have a dual competence. So they might be engineers and athletes. They might have done work at Wall Street and being an athlete. They might have done one. Shika Tandon in our operational group was an Olympic swimmer for India. And then she got a master's degree in biochemistry and then did work in tech industry. So that combination, those are my favorite athletes. So she was at the very highest level of swimming and also a tech entrepreneur type athlete. And then we have Emil Blomberg in our team now, he's head of analytics. And is a world-class runner at the same time, which is super impressive to me.
Okay, all right. And then the next question I have for you, what is the best part of what you do? What do you love most?
The variation. The next day is never the same as the previous one. I think that is absolutely key for me. It's a lot of new things all the time. It's not stale. It's not definitely not 9 to 5, and it's never boring that way.
Okay, and then you always have a pros and cons. What are the sucks at what you do? What do you don't like doing?
So in my role now, I'm as a CEO, per definition, I only get to work on the problems because if things are working, there's too many things to do in a company. We're roughly 40 people now, so we're at a stage where you always have new people coming in and people leaving, and we have new products and old products and new clients and old clients and different types of problems, meaning that the only thing that lands on my table are the problems. If things are working, then I don't need to do anything with it. So I think that is the downside of the CEO position.
Okay, thank you. What would you love to share with our listeners at the end? Couple of final thoughts.
I'd like to share that it's a absolute paradigm shift and a bit of a revolution now. That everyone in this industry is living in a very very exciting time. So since I've been in this industry or with athletes for 20, 27, 28 years, in those early days, it's a completely different world now compared to last millennium. In that we have the data, we have the capability, we can do things in a completely different way than was done not even 25 years ago, but 10, 15 years ago. And that we should all embrace that and build on it and find a way to have the AI capability and the data handling and the monitoring and all of that work hand in hand with the human, so that we leverage the best aspects of human interaction and community and grouping and have the data and the analytics and everything as a base to start from.
Yeah, awesome. Michael, thank you. As I said, thank you for sharing your knowledge. It was great to have you. And it was just a really interesting talk.
Thank you very much. Thanks for having me on the podcast, and good luck with everything in the future.
Thank you.